Okay, so hello everyone. So this is a special definition or a general definition of allegation. Okay, so in this video, I would like to give this definition so as everyone can use it in different problems involving allegations. So what is allegation? So allegation is a method of obtaining a mixture's unit value in terms of its components values, unit values especially. This is a unit values as their weight mean value. Also, this is a unit, the weighted mean value is the unit value of the mixture. So unit value of the mixture. Okay, so now in this regard, we have two main types of allegations. The first type of allegation is allegation medium. So another kind of allegation is the allegation alternate. Okay. So now, what is the allegation medium? So now, when the weights of the components unit values, the weights of unit values of the components of the mixture, when they are used to determine mixture's unit value, as I mentioned, in that case, the allegation in question is allegation medium. That is the first case. Another case, when the mixture's unit value is desired, now is used to determine the weights of the components unit values. In that case, the allegation in question is allegation alternate. Okay, now somehow we can understand this by means of an example. So in our example here, we can take an example of a mixture commonly known as concrete or cement concrete. So cement concrete has components of the mixture. The concrete is, we have cement, and we have sand, and we have aggregate, and this will make the component of concrete. So the mixture is actually concrete. So now we have two types of allegation we can make. The first one, so it is the allegation medium. So in allegation medium, in this case, we have a mixture that is called the first one cement with the first quantity, the second quantity, third quantity, and it will make the mixture. The total quantities of the mixtures will make the total quantity. Partial quantities, some of them will make the mixture. So now, for each quantity, the first quantity, suppose it has a value P1, second value has a value P2, and the third P3. So now we would like to find the unit values not only of the first, second, third component, but of the mixture. Let us call it P bar. So P bar. So now that is the question in alligation medium. Now in this case, we can use the ratios of the quantities in the mixture. So first quantity, suppose it is 1, second, it is 2, third, it is 4. So these are ratios which are commonly used, so not as so common, but that ratio can be found when we are dealing with cement, sand, and aggregate in order to make concrete. Now, in this case, these are what we call, this is the ratio, but the ratio of weight. These are weights, these weights are not exactly normal weight, normalized weight. And in this case, the weight of the unit component is going to be equal to 7. So that component, that mixture unit value has weight 7, and this one unit 4, this one will have unit 2, and this one will have unit 1. Unit 2, unit 1, I mean weight 2 for unit value of the second component, unit value of the third component. Okay, so now, so this is a weight of the fourth, the mixture, unit mean value of the mixture. Now the question is, in medial alligation medial, it is to find the unit value of the mixture given the unit values of the component. Okay, now in this case, what will happen, how to find the weighted mean value. So we can normalize the weight. For example, the first weight will be 1/7, some of these weights which are not normalized. And then the second one will be 2/7. Third one will be equal to 4/7. Okay, in that case, now we can respond, we can have an answer to the question. So the question, and the answer is, in this case, answer is the weighted mean value, the unit weighted mean value, unit value of the mixture is equal to W1, P1, W2, P2, plus W3, P3. In that case, this is the answer for alligation medium. Okay, now what about another case? So we would like now, so in this case, how to find the ratio, the continued ratio for the whole mixture. The continued ratio will be ω1/ω2, so which will give 1, and the ω2/ω1, ω2/ω3, which will be just 2, and so this will be the ratio, and then the last one will be the this one 1/2, and this, the second one, will be so these two ratios, I think they are enough, because this one over this will be exactly, no, this is a mistake. You have 1, this one divided by this, you have a half, the first ratio. The second one will be Okay, let me just correct myself. Oh, this is wrong. This is wrong because this is already the continued, the ratio of overall ratio is this ratio. Okay, now suppose we want ratio for the first weight divided by the second weight. We're gonna have, it will be 1/2, a half, and the second one will be omega 2 over omega 3, which will be also be a half. 2/4 is like a half also, 1/2. Okay, now this is one of the question of the alligation medial problem. Now we're gonna move to the second one, alligation alternate. In this case, the second situation. And before we move to the second question, so we can answer the question. If we have for alligation medial, 1 omega 1 P1 omega 2 P2 plus omega 3 P3. Suppose we know the ratio 1, 2, 4, and suppose we know unit value for each quantity. Suppose P1 is equal to, take 200, P2, suppose it is equal to, let us take 45, P3 for the aggregate course. Aggregate will take 50. Let us say so. Now, how to find the unity value of the mixture? Okay, so here we go. We have, this is equal to omega 1. It will be 1 divided by 7. It will be omega 1. P1 is 200 plus 2 divided by sum of these, 2/7, 45 here, plus now 3, it is 4, omega 3 is 4/7 times 50. Okay, so now in this case, we're gonna have common denominator 7. Now 200 plus 2 times 45 is 90. So plus 4 times 50 is 200. Now numerator 200 for 400 times plus 90, it is 490. So upon division properly, so you are going to get a unit value of 70 in this case. Okay, so now as I told you before, so the second alligation type is so alligation alternate. So what is the question in this situation? Suppose we have P1 equal to is given, P2 is given, P3 is given as P3 is given as unit price for aggregate, P2 is unit value for sand, and P1 is unit value for cement. So in this case, and also now here, the unit value of the mixture also is given. Suppose we know all these four values. Now the question is how to find the ratio. Among the ratio we have 1, 2, 4, but this would be the answer when so it means the prices are given or the units are given, the values are given, unit values are given, and we want to find the ratios between the unit values of the component. In that case, this is a question, and the answer is this. But in this case, if only we have these three unit values, and the unit value of the mixture are the only things, the only data given. In that case, we have how to find this ratio. Now, we are going to see that this equation is, you can see it is one equation with 1, 2, 3 unknown. It means that we have to set two values, like the second, the third, as parameters, and express and have so many solutions to find the ratios. So in the next video, we are going to show that in case already the prices are given, if there are more than two prices or two, I said prices because unit values may be prices, may be percentages, may be some other values that describe the quality of the different quantities, quantity 1, quantity 2, quantity 3, and so on, if you have many quantities. So in that case, we are going to prove in the next video that there are many combinations, many ratios, not only 1, 2, and 4, which can be obtained from these 1, 2, 3 values for the component, and the unit value like 70 for the mixture's unit value. Okay, now, so I think this is the end of our presentation on alligations definition in case we have a problem involving alligation. Thank you very much. Now, let us meet next time in another video, in which case we are going to show that when we have 1, 2, 3 values, for example, in the case of concrete as a mixture, and if we know the unit value of the mixture, like here P bar, which is 70, so we can find infinitely many ratios like this, which will solve our problem of finding the weights, because from this we can have weight 1 will be equal to 1 over 1 plus 2 plus 3, 4. The second weight will be 2 divided by 1 plus 2 plus 4. The third weight will be equal to 4 over 1 plus 2 plus 4. Okay, which is this sum. This is the weight of the unit value for the mixture. So let us continue. We are going to continue and finish up this problem of showing that there are infinitely many solutions or many ratios for which we have for the same prices, for the same values, we have the same unit value for the mixture. Okay, so until then, keep watching my channel as I'm preparing so many videos to come. Thank you very much.